631, I'm going to mark the attendance for today. The first section, 644. 644, we have Kaida here, Michael here. Is Max here? Max? No. So the second session, 909. Jose is here. Elisa Hallie is here. Eliza is here. Bailey, is Bailey here? Ether is here. Think I don't see. 2, 3, 4, 5, 6. Okay. Save. Let me share the file. Study guide. Okay, today we are going to review for exam 1, unit 1 exam. I have posted an announcement regarding the time and the location of the exam. Please read the announcement. This is sample test, very highly similar with the actual test. We have 80 minutes. Same with the exam, you have 80 minutes for 20 questions. So averagely, you have 4 minutes for each question. Let's get started. Let me double check I'm recording. Yeah, I'm recording. Okay, everything seems fine. You can see my note, right? I believe.
Yes.
Okay, very good.
Can I ask something real quick, Professor?
I'm sorry?
Can I ask one question real quick? It's not going to take time.
Okay, go ahead.
Okay, so those questions we are having, because I've been working on the review also, are we getting similar questions? I know it won't be the same figure, you know. Should we be expecting similar questions with this study guide, from like something similar to this study guide?
Yeah, I said highly similar.
Highly similar. Okay, thank you.
Yeah.
Thank you.
I guess a couple of them or a few of them even exactly the same. One thing I'm not sure is the system randomly generated the numbers. So when I say maybe 2 or 3 of them are exactly the same, it's just exactly the same with my test. The other day when I look at the test, it might be different. The numbers might be different from the numbers you see on your test, but highly similar. Okay, let's get started. Number 1, in 1991, the moose population in a park was measured to be 4,780. By 1997, the population was measured again to be 6,340. If the population continues to change linearly, find the formula for the moose population P in terms of T, the years since 1990. Important information here is T. Okay, here. T is the years, number of years since 1990. That means we see 1990 as the initial years. Initial year. The first part of the problem is to find the formula that could model the linear situation. And we're going to use the slope-intercept form to write the answer. We know the slope-intercept form is y equals mx plus b. M here is the slope, or rate of change. B here is the y-intercept when x equals 0, or the initial value of the y. Our y here is p of t, our x here is t, and let's see what is our slope, what is the rate of change. M here supposed to be average rate of change of the moose population per year, all right? So let's see how do we get that done. What do we have here? We have in 1997, the population is 4780, and okay, sorry, my bad. In 1991, population is 4780, and in 1997, the number becomes 6340. So the most is the population is getting bigger, right? Is increasing. So the slope is going to be positive. Let's see, what is 6340 minus 4780? So 0 and 651, 1560. So the population has gone up this much over how many years? Over 6 years, from 1991 to 1997, that is 6 years. So we're going to divide 1560 by 6. Let's see, what is that? I think this might be faster. I just manually calculate instead of getting the app. It's faster for me. So we have 260. And if I got anything wrong by accident, please let me know. So I got a readout change 260. Do you have the same thing, everybody? Huh?
Yes.
Okay, so the slope is 260. What about the initial value? Initial year is 1990. If every year the population increased by 260, then what's the population of the moose population in 1990, which is the initial year? Would it be smaller? How much is smaller? Smaller than 4780, right? How much is smaller? I think I'd better use a calculator just to get it fast. Use this one. So 1991, the population is 4780 minus 260. I got a 4520. 4520. 260. Yeah, 4520. That's the population of the moose in 1990. That's gonna be the B, all right? B is the initial value of the population. Initial year is 1990, so our B here is 4520. So the model is gonna be P of T equals 260 T plus 4520. Right? So if we plug in T equals 1 year after 1990, which is 1991, then we have 260 plus 4520. That does give us 4780. That matches the given information. And if we plug in T equals 7 in 1997, so if we multiply 260 by 7, just play with the 260 by 7, and then add that on top of the initial value, which is 4520, 520, and we have 6340, and that's the given information as well. Very good. So that's the first part. We give the model, the formula that model the linear trend of the moose population. The second part, what does your model predict the moose population to be in 2006? Okay. How many years that is after in 2006? How many years? 2006. So 1990 is the initial year. 1996 is gonna be 6 years after that, and then that is 16 years. Do you agree? So T equals 16. Yeah, T is supposed to be equal to 16. So part 2, all we need to do is we plugging in T equals 16 here. All right. Let's use a calculator. 260 times 16. That's the increase over the 16 years. Add on top of the initial population in 1990, which is 4520. 4520. A6A0. A6A0. So that's answer for part 2. Are we good? How many minutes do we spend? Oops, 10 minutes. I hope some of the 3. Find the domain and range for the function graphed below. This one is very easy. The domain, if we write as an interval, it starts from -1 and end at 2, right? And left closed, right open. And range, vertically speaking, the graph has a boundary from the below, which is 0, has a boundary from the above, which is 4. And the lower bound is included because we have a circle here. And the upper bound is included, so it's a bracket. It's a bracket. So that's number 3. Number 4, an interval. Okay, which one is this? Is number 3, right? This is number 3. Number 2. The next question. Find the domain of the function f of x equals square root of ax minus 7. Since it's a square root, so the radicand has to be non-negative. The radicand here is ax minus 7. It has to be bigger than or equal to 0. And we solve this inequality by add 7 to each side. And then we have ax is bigger than or equal to 7, divide each side by 8. We have x is bigger than or equal to 7 over 8. And that's the domain. Any real numbers bigger than or equal to 7 over 8, that's the domain. And the interval notation would be 7 over 8, comma, infinity. Left closed, right open. Because we have a bar here, that means 7 over 8 is included. So that's the problem. This number 4. The graph of 1 over x is shown on the Cartesian plane. Find the domain and range. So this is the famous reciprocal function, y equals 1 over x. And it has a branch in quadrant 1, it has a branch in quadrant 3. And the domain is all real except 0. The way we express all real except 0 in interval notation is net infinity to 0, open, open, union 0 to past infinity, open, open. Same with the range. Because the function is symmetric, if you switch x and y, you get the same function. So the range is the same, all real except 0. This is how do you express all real except 0. So that's easy as well. Next question. Give the intervals of increase and decrease for the graph above. Warning, there may not be 2 intervals for each part. If you don't need an answer box, leave it blank. Increasing on the interval, decreasing on the interval. Okay, so let's find the increasing. Let's find the interval in which the function is increasing. All right, I'm gonna use color scheme. As we can see, this part is increasing and this part is increasing. And we are looking for the x values, right? And so this should have an arrowhead. So it's from net infinity. The first piece is green. Start from net infinity, ends at -2 right here. You're gonna always use open interval, all right? The problem will specify dry open intervals. Yeah. This problem doesn't mention it, but the problem you see on the exam will specify, give the interval as an open interval. So you use parentheses, parentheses, left-handed parentheses and right-handed parentheses. So that is the one interval, the graph is increasing. The other interval, the second piece, green, the second green piece, start from 1 and then go to infinity, right? So 1 to past infinity. So over those 2 intervals, the function is increasing. And let's see the decreasing. There's only one piece or one part of the graph is decreasing. And the decreasing interval is from -2 to 1, right? It's decreasing, and those two increasing. So that is that question. Next one, function composition using graphs. All right. We are given two graphs. They represent the function f, the one on the left, and the function g, the one on the right. And you can see function f is very complicated, and the function g is just a straight line going down. And we need to find f of g of -1. Okay, I think I'm going to explain this as ensemble line. This composite function has g as the inside function. So the input are going to go through g first, and then go through f, since f is the outside function. And the input here is in the parentheses. The input is -1. Let's see, if we give function g, so we're going to look at the graph on the right, right? If we give function g, look at the graph on the right, input -1, input -1, where's -1? This -1. Input is the x value, right? And the corresponding output is -2. You see that? Yeah, when you give the input -1, the output is -2. And -2 now is going to go inside machine F. So now we're going to look at the graph on the left. When the input is -2, right here, this is -2, the output is -6. So the answer here is -6. All right. Now let's look at the second part. The second part, we are looking for g of f of -2. The input is -2. Inside function is f. So this time, the input is going to go through machine F first, and then go through machine G. Let's see. When the input -2 goes through machine F, we're going to look at the function on the left, the graph on the left. Input is -2. We actually had it earlier, right? 92 is here. Go down, the corresponding y value is 96. So the side product is 96. And then 96 come out from machine F, and they're gonna go inside machine G. So we're gonna look at the graph on the right side. When the input is -6 is right here. And the corresponding output is 3. So the answer for the second part is 3. All right. And then you will have another 2 parts for this type of problem. If you have a part for this problem asking you to find f of f2, do you know how to do that? If you need to find g of 3, do you know how to do that? The same idea, right? This ensemble line just have 2 machines. Both 2 machines are f. And this ensemble line has 2 machines. Both of them are machine G. The idea is the same. So that's that problem. Next problem. Write the equation of the circle centered at 4, 93 with radius 9 in standard form. This problem gives you the formula, but the actual test problem does not give you the formula. You need to understand and memorize this formula. So h is 4. All you need to do is plugging in, right? X minus 4 to the power 2 plus y minus 93. It is y plus 3 to the power 2 equals r is 9. 9 squared is 81. And that's the formula of the standard form of the circle centered at 4, 93 with radius 9. Very straightforward and basic. I don't think this is challenging at all. But last semester, we don't have a good passing rate for this specific problem. You just need to memorize the formula. Next question. For each equation below, determine if the function is odd, even, or neither. And you're going to have something like that. You have 3 functions. Not necessarily one odd, one even, or neither. Okay, I'm not sure. You would have to check. Let's check f. First, I know the domain of f is all real, so the domain is fine, is symmetric. And we want to know what is f of negative x. Go ahead to find the f of negative x. So the input, when the input is negative x, we're gonna change all the x to negative x. Change all the x to negative x. Like that, right? Input is a negative x, so the corresponding output is this. And then simplify. Negative x times negative x times negative x is a -1 times x cubed. And then plus negative x is minus x. So now we have -2x cubed minus x. We can factor -1 out. And inside the parentheses, we have 2x cubed plus x. Inside the parentheses, that actually is our f of x. So we find out f of x, we find out f of negative x is the same with negative f of x. And that's the condition for odd function. This is odd. This one is odd. G. Function g is 1 over x plus 2. So the domain is all real except 0 is symmetric, so it's fine. Domain is fine. And let's see, what is g of negative x? If we replace x with negative x, we're gonna have this, and this is not equal to g of x. Is not equal to negative g of x either. Just imagine the reciprocal function graph is shifting upward 2 units. We had the curve earlier for the domain. This is the hyperbola. G of x equals 1. This is the hyperbola corresponding to the reciprocal function. Imagine you move this curve upward. How many units? Like 2 units. And the graph is not going to be symmetric with respect to, oh, hold on. This curve, yeah, is not going to be symmetric with respect to y-axis or symmetric with respect to the origin. We know the geometric significance regarding odd function, even function, right? If it's odd function, the graph is symmetric with respect to the origin. If it's even, then the function is symmetric with respect to the y-axis. This one is neither. And algebraically, we also shown is neither. Okay, the function g here, neither odd nor even. H. Domain is all real, so it's fine, it's symmetric. And the h of negative x is negative x to the power of 2 plus 2, and that is x squared plus 2. Okay, negative x times negative x times negative x is positive x squared plus 2, which is equal to h of x. And that's a condition for even function. Even function. And this one is odd, the other is even, and one is neither. So this is a good problem. Next, that the f of x is 4x minus 7, g of x is x squared minus 4x plus 7. Then we are looking for the composite function, f circle g of x. So we want to rewrite the notation as f of g of x. Inside function g, outside function f. We're going to get rid of the inside function first. Inside function is x squared minus 4x plus 7. Pretty big, right? But just see that as one whole thing. Maybe a piece of green, right? That's the input. That's the input. And the output for function f, look at it here. The output for function f is 4 times input minus 7. So the corresponding output when the input is green is going to be 4 times the green minus 7, okay? 4 times green, x squared minus 4x plus 7, and then minus 7. So this is the green. Okay, let's simplify. Yeah, this part is just about algebra. We have 4x squared minus 16x plus 28 minus 7. And here we have 4x squared minus 16x, 21. And this is the result for the first part. The second part, G circle f of x is g of f of x. Inside function is f, outside function is g. So the inside function is f. We're going to put the inside function 4x minus 7 here. I'm going to change the color to this time blue. The input is blue. For function g, when the input is x, the output is square of x minus 4x plus 7. So the output is square of the input minus quadruple of the input and the plus 7. When the input is blue, then the corresponding output would be the blue to the power 2 minus 4 times the blue and the plus 7. All right, so we're going to have blue here, and blue here, and the blue here is 4x minus 7. What I worry about this problem is the algebra part. How do you simplify? That might challenge some people. So 4x minus 7 to the power 2, I'm going to use the formula you learned from Foundation 2 to expand this expression, removing the parentheses. We have 16x squared minus 4 times 7 is 28, double 28 is 56, and then plus 7 times 7, 49. And then minus 16x plus 28, and then plus 7. And then simplify, we have 16x squared. We have this negative 56, negative 16, added together is a negative 72. All right. (72x), and then this is 49, is 28, is 7, so that's 35, 35, 49, 84. Yeah, what I worried is this part, a lot of algebra, a lot calculation. Let me double check just a little quickly. That is 35, 84. Yeah, okay. So that's about composite function. Next, we are given function f. This one is pretty simple. Input, output. Knowing input is always in the parentheses. So the first part of this problem is you are given the input 92, you are finding the output. This is the output, okay? F is the function, f is the function. So the value of the function, we can understand that as the value of y, the value of the output. Okay, so all we need to do is to plug it in. 6 when x equals 92, plug in x equals 92 and minus 3. 6 times 92, negative 12, minus 3, negative 15. So the output of the function f is negative 15 when the input is 92. Part B, solve f of x equals 27. So part B is the other way around. Same function f. What we are given is the output. Knowing the output is 27, we are looking for the input, the corresponding input. So to do that, this is what you do, okay? Write 6x minus 3, which is f of x, right? Yeah, f of x is 6x minus 3. If f of x equals 27, then 6x minus 3 equals 27. And we are going to solve this equation for x. Add 3 to both sides. We have 6x equals 30. And then divide by 6, we have x equals 5. When the input is 5, the machine produces the corresponding output equals 27. So this is a pretty basic. Part A, you are given input, you are looking for the corresponding output. Part B, you are given output, you are looking for which input, the machine, produce output 27 for. Okay, next one. The table below gives the annual sales in millions of dollars of a product. Row 1, years, 1998, 1999, 1999. 2000, and all the way to 2006. Second row, sales, 280 in millions. What was the average rate of, okay, just the average rate of change of annual sales. Just a yearly, is the sale increasing? Oh, not necessary, right? Not necessary. Sometimes increasing, sometimes decreasing. Okay, between 2000 and 2001, okay, 2001. Between 2000 and 2001, what's the average rate of change of annual sales? Okay. In 2001, the sales 406. In 2000, the sale is 376. Over that year, the sale gone up. Gone up how much? 30? Yeah, gone up 30. And over from 2000 to 2001, that's 1 year. So the yearly change, the average rate of change is 30. So you have 30. All right, what was the average rate of change of annual sale? It's just 30 millions of dollars every year. And this make it very clear per year, right? You're gonna divide the change in the sales over those years by the number of years over the time period. And this one, for part A, is just 1 year. Over the year, the sale gone up 30, so the rate of change is 30. Part B, 2 years, from 2000 to 2002. I'm gonna erase that. (2000 to 2002). Okay. At 2002, the sales 424. In 2000, the sales is 376. It's gone up, right? Yeah. Let's see how much has gone up. It gone up 48. Let me double check the number. 4, 3. No. Hold on. This is 8, 4. It is, right? 4, 2, 4. Yeah. And over 2 years, from 2000 to 2002, that is 2 years. Over 2 years, the sales gone up 48. Then averagely speaking, every year it's gone up 24, right? So it's 24. That's part B. Pretty straightforward. Next, determine the equation of the line passing through the point 3, 14 with a slope m equals 4. Put your answer in slope intercept form. Okay. Put the answer in the slope intercept form. Okay, then our equation can be y equals 4x plus b. Where's the 4 coming from? Is given. Slope is 4, so we can write the target straight line as y equals 4x plus b, because m is given is 4. And how do we find the value of b? We have another piece of information to apply. The straight line passing through 3, 14. So we're gonna plug in x equals 3, y equals 14. Let's see what we have. Y equals 14 equals 4 times x. X is 3 plus b. 14 equals 4 times 3 is 12 plus b. And b has to be 2 in order for this equation to be true, right? Only 12 plus 2 gives 14. So b is found. B is 2. So the answer is y equals 4x plus 2. You should always double check your answer when you have a chance. And also double check your answer doesn't really spend too much time. This one we can quickly plugging in 3 and 14, right? 3, 14. 4 times 3 is 12. 12 plus 2 is 14. So the point is on the line. The order the pair does satisfy the equation. Also, the slope is 4, so everything match. So that's that question. Next problem.
Can I ask a question? Excuse me, Professor.
Yes, please.
Okay, for this question, number 12, so, I don't have to, finish solving everything. Just stop at that equation part, which is y is equals to 4x plus 2. I don't have to plug in those numbers.
No, there's nothing to plug
Okay.
in. Earlier, when we plug in x equals 3, y equals 14, is to find the value for b.
Okay.
But your answer is this. Your answer is an equation. That's a good question. Next problem. For the equation 3x plus 4y equals negative 12, find the x-intercept and y-intercept. I should have enough space here. So the equation is 3x plus 4y equals negative 12. X-intercept. This is the cue for finding x-intercept. To find x-intercept, make y be 0. And then solve for x. Let's do that. Make y be 0. Okay, make y be 0. So we have 3x. This part gonna disappear, right? 4 times 0 equals negative 12. 4 times 0 is 0, and that term disappears. So 3x equals negative 12 divided by 3, x equals negative 4. So the x-intercept is negative 4, 0. Please read the question carefully. The x-intercept is negative 4, 0, but the question asks you to, they tell you the x-intercept is a, 0. What is a? Okay, then you should just enter negative 4. You see what I'm talking about? They would tell you the x-intercept is a, 0. What's the value of a? Then you do not enter negative 4, 0. You just enter negative 4. So make sure you really read the problem thoroughly. I don't do that because I wanna, cover as many questions as possible. Sometimes I rushed through. I don't really but actually I include all the information that is given. My point here is read the problems carefully and thoroughly. There's a lot of details and useful information in the problem. Y-intercept. The cue is to find a y-intercept. Make x be 0 and solve for y. Let's do that. I'm gonna move to the next page. Here, maybe 3x plus 4y equals negative 12. And we're gonna plug in x equals 0. The 0 here. And that term basically disappear, right? 3 times 0 is 0. So we have 4y equals negative 12 divided each side by 4y equals negative 3. So the y-intercept is 0, negative 3. That's how do we find the x-intercepts and y-intercept for a given straight line. Very basic. It's not challenging at all. Very basic. Next problem is to find inverse. Let's see, I think I can just, get some space here. Function f is given. We are looking for the inverse. 4 steps, remember that? First step, replace f of x with y. Second step, switch x and y. Write y as x, write x as y. Step 3, solve this equation for y. I can switch both sides because eventually we want a y on the left side and isolate it, right? So I switch the two sides of the equation. And minus 1 from each side, we have 5y equals x minus 1. And then divide each side by 5. We have y isolated on the left side, and on the right side, we have x minus 1 all over 5. I think this is good enough. Or you can write the answer as, and the step 4 is to replace y with f inverse. And this is good enough, I think. If you want, you can, split it up. You have 1/5x minus 1/5. If you want to write the equation in the slope-intercept form, that's the result. I think the system will mark this as correct as well. That's inverse. Next, a rental car company charges $45 plus 40 cents per each mile driven. Part 1. Which of the following could be used to model the total cost of the rental where M represents the miles driven? Well, I have the answer. Some of them I have the answers. Is the first one, right? The reason is because the rate of change here is 40 cents. In dollar, that is 0.4. Every time you drive 1 more mile, then you pay $0.4 more, right? You pay $0.4 more. So the rate of change here is 0.4. Slope is 0.4. The flat fee 45 is the initial value of the cost. Even you don't drive nothing. When you get a car, you have to pay $45. So that's the initial value of the cost. Initial value of the function is the y-intercept. So 45 is the B. Do not confuse with the M. M is the X, basically, okay? Y equals MX plus B. Our X here, the independent variable, we use the letter M. M here, the formula is slope, which is 0.4. Y here is C because the dependent variable is the cost. Part 2, the total cost of driving 300 miles. That's just plugging in M equals 300. You can also use your common sense, right? Think about, you drive 1 mile, you pay 40 cents. If you drive is that 300 miles? Yeah, if you drive 300 miles, 1 mile you pay $0.4. You drive 300 miles, you times 0.4 by 300, right? But that's not all the cost. When you get a car, initially, you pay $45 flat fee. So add that on top of 45 is 165, right? It's just a lot of things, just a common sense. What was the value again? 165. So that's the answer. Next, select all of the following graphs which are one-to-one functions. See Luhmann section 1.7, question number 12. How do we determine if a graph a one-to-one function, guys? What does this mean? What does this mean? VLT, vertical line test. HLT, horizontal line test. If the graph passes both, then the function is one-to-one. Then the graph is one-to-one. If the graph passes vertical line test, the graph represents the function. On top of that, if the function also passes horizontal line test, then the function is one-to-one. I think you can do this on your own. So I'm not gonna spend time on this just in case we don't have enough time. So I'm gonna keep going. Next question. This is number 17, right? Okay. Find the inverse. Maybe I can do insert page break. Okay, this is number 19. Okay. We are given function h. Find the inverse function. This might be a little bit challenging than the previous problem that required the same thing. Because earlier, the function we found the inverse, the given function is linear. It's pretty easy to find the inverse function for a linear function. But this one is hyperbola. The x is in the denominator. It might require a little bit higher ability of, handling equations. Let's start it. Firstly, step 1, replace h of x with y. Y equals 5 over x plus 8. Step 2, interchange x and y. Write y as x, write x as y. Step 3, solve for y. Yeah, this part is challenging. How do you solve for y when y is in the denominator? So firstly, I'm going to switch the left side and the right side because I want a y on the left side, right? So 5 over y plus 8 equals x. This step, all I did is switch the both sides. And then in order for y to come outside the denominator, is not, right now y is trapped in the denominator, right? We're going to do this. We are going to flip the top and the bottom. So we can write the right side also as top over bottom, right? Both sides now are in the format of a quotient. And the left side, I'm going to flip top and bottom. I flip it. We're actually taking the reciprocal. So as long as we apply the same treatment on both sides of the equation, that is fine. So on the left side, I flip the top and the bottom. On the right side, I'm going to do the same thing, 1 over x, right? And then we're going to multiply both sides by 5. 5 over 1, 5 over 1. And then those two cancel. And we have y plus a on the left side isolated. On the right side, 1 over x times 5 over 1, we have 5 over x. One more step, minus 8, cancel. We have y equals 5 over x minus 8. If you don't see this in the result, I remember this part is a multiple choice question, you might have to transform a little bit more. Step 4, replace y with f inverse. For the transformation, I'm going to use a different color. Oh, I just see we have a chat. Okay, thank you for your response. Let me use a different color. Use blue. 5 over x minus 8 is 5 over x minus ax over x, right? We can write 8 as ax over x. And now they have the same denominator x, and then we solve the top 5 minus ax. So it's a multiple choice question. If you don't see this, you might wanna transform a little bit, and you might see this. By the way, the actual problem for this one is closer to the problem we went over in a class, in a guided note. This one actually is simpler, but similar. That's number 19. Next, for equation 3x plus 4y equals -12, complete the table. This one is pretty simple. Basically, you just plug in y equals 0, right? And you have x equals -4. And the second row, you plug in x equals 0, you have y equals -3. So basically, it's testing you find the x-intercept and the y-intercept, but they give you a table. And part B, plot the 2 points you found in the table. And -4, 0 on the x-axis, 0, -3 on the y-axis. You plot the 2 points. That's it. And number 20, sketch a graph of this. The actual problem of this piecewise function graphing also has 3 pieces. Yeah, this one has 3 pieces. I remember first piece and the third piece might be horizontal, constant, just horizontal line segment. The middle piece is a more complicated function. But this one is the closest that I can find in Lumen. Yeah, one thing I think Pearson might be better than Lumen is they have more practice. It has more questions for you to practice. And this one sketch, we covered this problem before. I'm gonna do this again. So firstly, we are going to identify the domain of the function. As you can see, the three pieces, the first piece is from -infinity to -4, 94 included. The second piece from 94 to 2, 94 excluded, 2 included. The third piece from 2 to infinity, 2 excluded. So if we put the three pieces together, then infinity to 94, union 4 to 94 to 2, union 2 to infinity, that is all real. So domain is all real, but it's just indefinite. But the piecewise function has different mapping, different formulas for different parts of the domain. There are three parts in the domain. We're gonna color them differently. Infinity to 94. Second part is from 94 to 2. This question might be challenging, but you don't need 100% to get an A, right? You only need 90% to get an A for this course. And then the last piece, I'm gonna use pink maybe. All right. First piece, the blue. The machine is the same machine but different mapping. The mapping is y equals half x plus 6. In the blue region, we're gonna have y equals half x plus 6. It is a straight line. It is a straight line passing through 0, 6 because that's the y-intercept, right? Slope is half, so go up 1, go over 2. And we also can write the slope as -1 over -2. That means go down 1, go to left 2. Go down 1, go to left 2. Go down 1, go to the left 2. Continue, go down 1, go to the left 2. Yeah, the reason is because we don't really need the graph in the yellow or pink. We only need the graph show up in the blue. So be flexible. Your slope, yes, is 1 over 2, very convenient. But in this case, you write the slope as -1 over -2 is more convenient because the rise is -1, run is -2. Then from the y-intercept 0, 6, you can go down, go to the left, go down, go to the left. Then you will go to the blue region, right? Blue region is what you want. And let's draw the graph in the blue region. We have a straight, actually, we have a ray here. We have a ray here. And at 94, we have a solid point. That's blue, first piece. Second piece, in the yellow, the mapping kind of like the program of the machine, right? The machine based on the programming to produce corresponding output for the given input. The middle piece is y equals 91. So regardless the input, doesn't matter what's the input, the output is always 91. We also know this is a horizontal straight line. Let's draw the graph. Horizontal straight line x equals 91. Y equals 91. So in the yellow, we should have this line segment. Y equals 91. Y equals 91. But we're gonna have a circle here and a solid point here. Okay, make sure we know we have a circle here. Because the second piece, 94 is excluded, 2 is included. The third piece in the pink, the function, the map is y equals 90 half x plus 4. Is a straight line again. And the y-intercept is 0,4, 0,4 is here. So I want to go to, so the slope, I'm going to write the slope as 91/2. So my rise is 91, my run is +2 because I want to go to the right, go to the pink region, right? So rise 91, run +2, go down 1 unit to go to the right 2 units, 2 units. Go down 1, go to the right, go down 1, go to the right 2 units, go down 1, go to the right 2 units, go down 1, go to the right 2 units, and you can draw this part, the part in the pink region. Is array, technically it's not array because we have a circle here. We have a circle here. And that's the graph of this